For this question, which is also an impulse question, we need to find out the impulse of this baseball. I'm sorry, it's a golf ball. Okay, that is leaving from rest, which a velocity of 0, is changing to velocity of 42 meters per second. So because the delta v is a change in velocity, the initial velocity is 0, therefore the delta v will be 42. Now the first question is, what's the impulse of the golf ball? The impulse can be calculated two different ways. Force times the time, which since we don't know the force, we won't be able to use that part, or the mass times the velocity, the difference in velocity. So this is what we're going to use. So for the A part, the impulse will be equal to the mass, which so I'm going to say m times delta v, which is equal to, mass is 0.05, that is Bella, stretching, times the difference in velocity, which is 42. Okay, so what that would be, I'm using the calculator, and the answer is 2.1. And 2.1 what? 2.1, 0.05 was kilograms times meters per second. So that was the impulse for A. Now, what is the force extended to the golf ball? Now we have to use the other part. However, it's good to know the right side of the equation, because we already know the impulse. And because we know the impulse, what we're going to do this time, and I'm going to use the word here, we're going to use the formula force times the time equal to the impulse, which is, we just found it is 2.1. The time is 0.0007, so all we need to do is to divide by that, and we're going to find the force in 2.1 divided by the time, which was in seconds. And in the end, and again, I'm going to erase the seconds because I'm going to write the unit at the end. Everything is kilograms, seconds, meters. So we're going to end up with newtons. So 2.1 divided by 0.0007. And that comes exactly at 3,000 newtons. That's a pretty big force, if you think about it. Okay. The C part is if the golf ball is hit with a force that's changing the impulse. Okay, well, if it's changing the impulse from to the 3.6, that means we're going to have two different velocities, because the first impulse is changed to the second impulse. The problem actually is not referring to changing the impulse from the previous one to this. This is a total different situation. So we do have the same ball and the same mass. The problem here is not that it's changing from the impulse from A, because we apply a different force here. So it's like we start from scratch. So what we have to deal with here, well, we do know the impulse is Ft, so this quantity will be changed with 3.6. So we're going to have to say, we're going to substitute with 3.6 kilogram times meter per second. And that is going to be equal to the mass of the golf ball, which does not change. The mass is 0.05 times, now here is what happens. The velocity is changing here. So we go from in an initial velocity to a final velocity, and the final velocity is, we don't know, so we're going to have to put a V but the initial velocity, it was 42. And this is in case that we actually hit the ball a second time, because the first velocity was 42, and then someone hits the ball again. It is switching the impulse from that. This is what happens. However, if we assume we start over from fresh, the initial velocity would be 0, right? The initial velocity would be 0. So that would be a total different situation. So in this case scenario, you have a fish tail. You can either have a situation where you change the velocity of the ball because you hit the second time. So the first player hits and then someone else is hitting the ball that's in the air at that speed. It will totally change the problem. However, if we're dealing with from fresh, we hit the ball from the beginning, the final velocity we're going to have to find out from the second formula. So I'm assuming is hitting the second time, so I'm going to apply the first formula. You're going to have to divide by 0.05 first. So I'm going to say 3.6 divided by 0.05. And that I'm getting 72. So I'm having 72 equal to final velocity minus 42. If I add this with 42, is giving me 114. The final velocity is 114 meter per second, which is a lot. It's a lot. Now, if we start from fresh, from 0, so this is in case that is a second player and hits the ball after the first one took off, then is just divide by 0.05, and in this case it was 3.6. I am dividing again because it was 72. I forgot how much it was. So the velocity would be 72 meter per second. So they're both high speeds, but I tend to lean to the second answer because we are assuming this is, even though this problem should use the same information normally how they state at the beginning. However, this case scenario, my opinion, I think I would go with start from fresh, where it's just one player, isn't there, not two. So far, this is what we get.